Moving towards next question, we have A, B, C, D, it's a square. A, B, C, D, it's a square. Having area 100 square units. Having area 100 square units. And the triangle DEC. And the triangle DEC having area 10 square units. Having area 10 square units. Furthermore, let me repeat, ABCD is a square with area 100 square units. With area 100 square units. And furthermore, the triangle DEC having area 10 unit square. 10 unit square. Furthermore, EC is equal to ED. These two sides are congruent. These two sides are congruent. What is the distance from A to E? We are interested in the distance from A to E. From A to E. We are interested in this. We are interested in this. Let's utilize some information that we have given. We have given a square. We have given a square having area 100 square units. 100 square units. Area square is given by side square is equal to 100. Taking square root both sides, we have side is equal to 10 square, 10 units, 10 units. So each side is of 10 units, 10, 10, 10. Because it's a square, in square all sides are equal. We have utilized the fact area of the square is 100 square units. Area of a square is 100 square units. Side square, or some people write x square is equal to 100. So side is equal to, taking square root, side is equal to 10. Side is equal to 10. Side is equal to 10. So side is 10. So this DC is also 10. This DC is also 10. This DC is also 10. Furthermore, we have given the triangle. This is D, C, this is E. From this, the dimension of DC, the length of DC is given to us. The length of DC is given to us. Furthermore, DE and EC, they are equal. DE and EC, they are equal, having area 10 square units. Having area 10 square units. If I draw a perpendicular bisector, then it is 90, it is 90. Having 5 units length, it's 5. It is perpendicular bisector. Perpendicular bisector. Perpendicular bisector. Perpendicular bisector. Let me name it F. Let me name it F. So, area of any triangle, area of this triangle is equal to area of this triangle. They are both congruent triangles. They are both congruent triangles because this side is common, this side is common, belongs to DEF as well as EFC. This side is common. Furthermore, this DF is 5, this DF is 5 as well as FC is 5. DF is 5, FC is 5. Furthermore, it is given to us DE equal and EC equal. By the virtue side, both triangles are congruent, side. Taking any one portion from this, let me take D, F and E. It's a right triangle, it's a right triangle, it's a right triangle. We can safely conclude that we can find its area as area of this triangle is given by 1/2 base into height. Base times height. Base times height. What is base? No doubt it is 5. It is DC total 10. F is the bisector midpoint of D and C, so it is 5. Height we are interested in. Height means it's our EF. We are interested in to find. Further, total area is 10 square units. Total area of this triangle DEC is 10 square units. Area of DEC is 10 square units, but this line has divided the triangle into two sub-triangles with equal area. 10 divided by 2, having this area of 5, this one as well as area of 5. So area of this Any single triangle is 5 square units, it's also 5 square units. Plugging in here 5, solving for EF, 2 times 5 divided by 5 is equal to EF. 5 cancel, EF is equal to 2 units. EF is equal to 2 units. Now our game begins. This is our 2 units. If I complete this one, this is also 10. This is also 10, and this is 5. DC is 5, AB is 5, this is 5, this is also 5. Let me slash out this portion that we are interested in. Here it is 2, it is 10. 2 plus 10, it is our 12. 2 plus 10, 12, it is our 5. And we are interested in A to E. A to E, and let me name it P. AP. Applying Pythagoras theorem, this is perpendicular, this is perpendicular, this is base, this is perpendicular, this is base, and our required AE is hypotenuse. Our required AE is hypotenuse. Applying Pythagoras theorem, I have h square is equal to base square plus perpendicular square. AE, we are interested in to find its length, is our hypotenuse, base AP, and perpendicular EP. Hypotenuse we are interested in, base is 5 square, and our perpendicular 2 plus 10, 12 is square. So we have h square is equal to square of 5 is 25, the square of 12 is 144, it is 169. Taking a square root of this one, taking a square root, so we have hypotenuse is equal to 13. Hypotenuse is equal to 13 units. So our EAE is 13 units. 13 units. 13 units. So our answer is AE. AE. What we have done, we have given the area of this square ABCD 100. Formula for area of square is side square or x square. X square is equal to 100. Taking square root, x is equal to 10. Each side 10. This is also 10. This is 10. This is also 10. Okay. Furthermore, this triangle is given to us having DE and EC are congruent. DE and EC are congruent, having area 10. We have dropped a perpendicular line. We have dropped a perpendicular bisector. EF on DC. It gives us DF 5 square unit 5 units, FC 5 units, DF 5 units, FC 5 units, and we have divided the area by 2 because they are both congruent triangles. Total area 10, 5 here, 5 here. It will area evenly distributed 5. So we have taken this fact 1 upon 2 base into height. Height is EF, we are interested in, and we have taken not 10, instead 10, 5, because we have taken only one half, either this, both are congruent, equal. I have taken 5 instead of 10. I have taken 5 because I have taken only one side, half of the triangle, half of the original triangle. Solving for EF, we have EF is equal to, plug in this, EF is 2, this is square having AD 10, DC 10, so this FP also 10. 2 plus 10, it is our perpendicular, and base is our 5. We have taken half of the base of the square, its AB is 10, AP is 5. Applying Pythagoras theorem, AE is our hypotenuse that we are interested in. Applying Pythagoras theorem, base is square, perpendicular, base is 5, perpendicular is 12, 5 square 25, 12 square 144, 25 plus 144, 169, taking the square root. So we have this length AE is equal to 13 square units. Moving towards next question, we have